There's two common types of ice tables that you can set up with this solubility and the solubility product. One was this ice table where we knew the solubility, which is the maximum amount of solid that will dissociate in a liter of solution, often listed as like moles per liter. Moles of solute that dissolves per liter of solution, which then kind of tells me the ion concentrations. That's the maximum concentration of copper and bromine that could be formed in a liter of solution. And from there, I could figure out the KSP. The other type of ice table looks a little bit like this. It's kind of the opposite, where now I've been given the KSP, the solubility product for copper 2 iodate. It's small, 1.4 times 10 to the negative 7th at 25 degrees Celsius, which means then that it doesn't go forward by much, that there's not a lot of product ion. This time we're going to calculate the solubility. So I think sometimes people just don't know, like, what are they asking me for? This time I want to know, like, well, how much of that copper 2 iodate will dissolve per liter of solution. So let's just start with an ice table. That's always a good place to start, right? So we're going to put our dissociation equation down first. My copper iodate, IO3, 2, would be a solid. And I want to know how much it goes forward to eventually produce copper plus 2 ions in solution. And I would get 2 iodate, O3 minus, in the solution, AQ. And then we're going to go ICE. All right. So initially, all I have is solid. I'm going to have some solid, and we're going to throw it in a container of water. Well, initially, you have solid, but we never care how much, because we're not going to use it in any of our calculations anyway. So you can set up the ice table, but maybe just scratch that initial amount of solid. It doesn't really matter how much I have. Initially, I do not have any product ions, just solid. So I'm going to throw that solid in water, and I want to know, like, by how far forward will it go? Like, how much does it dissociate? That's the solubility. The solubility is usually in units of moles per liter. How much of that solid will dissolve? Last time we were given the solubility. We knew how much solid dissolves. This time, that's what I'm looking for. Well, if I don't know the solubility, let's just call it X. Now I know that whatever amount of solid I have, let's say it'll go down by X. And some of it will dissociate. And whatever amount of solid does dissociate, then I'll get that much copper ion, and I'll get twice as much of the iodate. So we'll just put it in as X and 2X. So that at equilibrium, I don't really care how much solid is left over because I'm not going to use it. But I could say then that the amount of copper ion is X and the iodate is 2X. Well, now if I solve for X, that will tell me the solubility of the original solid. How many moles of that solid will dissolve per liter of solution? Now, in order to solve for X, we have to have the equilibrium constant, which we do. So this time I have the KSP. That is 1.4 times 10 to the negative 7th. Notice that they always give you KSP at 25 degrees. Or in the previous problem, they gave me the solubility at 25 degrees. Because we kind of know, like, if you increase the temperature of your solution, usually you increase the solubility. Like, more salt dissolves in warm water. But yeah, I mean, all of these guys have energy as part of the system, even though we don't always write it in there. So yeah, if you add energy, you're going to shift the equilibrium, which would change the solubility, and that would change the KSP. So often these values are listed at a particular temperature. Not that I care, but that's kind of why they usually give some kind of a temperature with the KSP. Here, I just want to solve for X. So I'm going to set it up so that my copper ion is X to the first, or obviously you can leave that out. And then my iodate is 2X, but I still need to square it, just like my equilibrium expression. All right, and then we'll simplify the best we can, solve for X. So this is going to give me 2X squared times X. How about 4X cubed? And now we'll plug it all in, solve for X. All right, so I'm going to divide by 4 and take the cubed root. When was the last time you took the cubed root of anything? It's kind of fun, right? All right, so I am getting about 0.00, oh, I don't know, I guess maybe just 33 moles per liter. And then we're done. That's the answer. That is the solubility. So technically the solubility is like this. It's the amount of that original solid that does dissociate. How much solid will dissolve? Oh, the maximum amount I can dissolve is about 0.0033 moles per liter. And again, if they ask me what would be the maximum mass, then I would just take 0.0033 moles of copper iodate and turn it into grams. So these are kind of our two ice tables. If we want to solve for the solubility, then we're going to set up our ice table with X, but we have to be given the KSP. In the previous ice table, we were given the solubility, which is like X then. That tells me how far forward I'm going to shift. Well, if I know the shift and I know then the equilibrium amounts of these two ions, then I can solve for the KSP.